Right. Hi everybody. I hope everyone is doing fine. Um, Welcome to this new edition, or actually the second edition of Juno Live. And yeah, so let's try to continue what we started last week. So just as a reminder, what we were doing, we were working on this suggestion that Sun had on GitHub. The idea is that we find a way to generate a JSON data for our data in the backend so that we have like an easy way to fetch those at runtime, right? And last week I'm gonna zoom in my editor here. I hope that's appropriate if you watch the stream on your mobile. So where we stand last week is that we have initiated our serverless function. We were reading the data that we were persisting from the front end. We were decoding those, and we were also saving that back after having changed their state. But maybe we just give it a try. That's gonna be easier. So I'm gonna start Docker because we were developing locally, right? Super. So what we had, also gonna start like a zoomed view. So I was here. I start the local replica, right? As always, if you have question, you scream. Okie dokie, and what I gonna do, because I've made some experiment this weekend to prepare the call, I just gonna rebuild the current status of our serverless function, so I'm sure that we have them installed. Super, and now I start the front end. So where did we were? We had our sample admin view. We can sign in, and you see I've made some tests. If we save a data, here you see we see let's go, and that's because in our serverless function we start with let's go, and then here I've written hello world, so if I refresh I should have hello world checked. Yeah, you see we have it here because I added this and then we save. But that's not exactly what we want to achieve. What we want to achieve is actually generate a JSON data for that we expose through HTTP. So we defined various steps we can do, and we concluded last week that there were some functions that were missing, and I've now added this function in the sense that if we go to the dependency of our smart contract here, I've created a new function that I've published in a patch of the library that is used by the satellites. What I generally do is like I generate patch for the library until there is like a version, and then when there is a version of Juno, we have the effective version that gets released. And I also had to add a new utility that we're gonna use, and I also had to make a small change in the storage because that's kind of recent, but there is a new library or a new crate for Rust, which is the storage, which extrapolates all the storage web capabilities of a satellite, because a satellite gives this asset on the web, but as recently, if you go to console.juno.build, all the assets comes also from a smart contracts, and that use the same technology. That's why I extracted all the codes from a satellite to put it in a library, and then the console and the satellite use the same create. So potentially, that's kind of really neat for the future. Okie dokie. So what we want to do now? Everything. We want to make this available as a JSON file on the web. And for remember, in a note, we have like a text, the text that I'm entering, and an URL, which we don't use here, but doesn't matter. So what we want to do is, here we have like a Rust struct, an object. So what the first things we want to do is transform that object into a string that we can expose on the web. To do so, create a new variable, and here there is like a new, it's encode actually, encode doc to string. That's a new function that I've built this weekend. And we paste the note. Hopla. That should be like this. And we're just gonna, as a first step, we're gonna print that out to the console. All right, so format JSON. Here we print that JSON, right? So let me build. Okay, here it should upgrade. Okay, so if now here I had like this is a test. If everything goes well, you see here we have the JSON. Okay, so that means that thanks to this new functionality that comes from Juno build utils, that's crates you can find at crates.io. You see here you have all the crates that are provided by Juno, and here you have that utils one updated two days ago. You see, I told you I did it that Saturday, and thanks to that we can transform into a JSON. Okay, so we have the JSON. So what we need to do now is push that somewhere so that it gets fetched on the web. So to do so, we're gonna use a new function that I have also added this weekend, which is called set asset handler. So it's a new function, but technically in the satellite nothing changed. It's kind of like I added a utility that use existing function. So let's check what does that things need. So here that's the JSON file. Sure, we're gonna need some headers, and we also gonna need an asset key. So let's start with the asset key. I command that way I can build. So we need a key. Okay. So what do we have in a key? In a key we have the name, which is the name of the file. So in our case it doesn't matter really since we are generating it on the fly. So let's just call it, I don't know, like notes.json, doesn't matter. Then we need a full path. So you know that also the full path from the JavaScript library, if you use it, it's honestly it's not a good name. if I would be like 1 year earlier, I would probably use another name, but it's just the name I came with when I started Juno, and it's too late to change it. So that's basically the rest of the URL. It's like if you go to, for example, Juno here, the full path would be /doc/intro. And if you go .html, so the full path is /doc/intro/index.html. All right? I don't know. Yeah, there is probably I would probably be more. In French, we say sometimes that you are always clever afterwards. So, yeah. So let's call it full path here. And you see that full path is not just the file name, it's also the collection. So here we're gonna need the collection. And then we're gonna have, for example, nodes.json. And yeah, so we need a collection here. So that means that to develop locally, now we need a collection to save those. So I head up to my, where is it? Juno dev config, and we already have nodes, images, but that data store, we want, no, that's a storage one, but I don't want to save that in images given that it's really particular. So, yeah, let's do that. We create a new collection that we're gonna name nodes, manage, and the stable memory permission. And here, if everything goes fine, the dev environment should notice that the file changed. I think, yeah, you see, and it applies that. So to not stress too much the image, I've set like 30 seconds. It means like every 30 seconds it checks if there is a change in the config, and if there is a config, then it updates. Yeah. So, all right. So we want nodes. So since we want to have nodes as a collection, then that's not like a really handy name. So what I suggest that we do is that we actually name the key, and we generate each time a node.json. So, and here I will parse the key, that way we have it. And here, let's call it, hopla. So we're gonna do a format here. And here we're gonna do key.json, okay? So just as a reminder, when you are in your hook, you get a context, and that context contains various information like the color, the original color of the not the color of the hook, but the color of the original endpoint that was triggered on the satellite. And then in the doc context, you get the collection, you get the key, which is what we're gonna use, and in the data, you get the data before it was changed and the data after it was changed. But here in our case, we're gonna use the key. And because I want to be a bit, so let's call it name, doesn't matter, like this. So here we're gonna use the name, yeah, and I don't need that, I guess, and I don't need that. And here we're gonna do a format. That way I just use, for consistency, I'm gonna use the same, what did I say? Yeah. So /node/name.json. Okay, so here we can have the name. All right. And yeah. So by the way, I hope that my mic works this week, because last week we had issue with the mic, but no one has said anything, so I guess it works out. So we have the full path. Now we need a token. We don't need one here, just as a reminder. So the token is like, it's adding a query param that makes the file kind of private, in the sense that only those that knew the token query param can access the file. For example, let's say here we would have a JSON file, so that's public, but if I had the token, it means that only that those who know the particular token can download it, so that if I would do that, I would not be able to see the file. Okay. And then we need a collection, because why not? And our collection is nodes, so let's do that. Nodes, like this. And here I'm gonna do that way, have it too. And here we're gonna do collection. And by the way, there is that checks. So why do I need the collection here and there? Then there is a check that when I upload an asset, the full path should start with the name of the collection. This is to avoid the storage to be used to push stuff in the root, because that will conflicts with the depth that you host in the same storage. Where were we? Collection, owner. So now we need to define who's the owner of that file. And given that we are generating it for a serverless function, I think a good owner is the smart contracts itself, and ID is the ID of the canister. So that's a function that comes from the ICCDK. And there is one last one, which is description. So we don't use that here. Description is a field that you can use to add some more information. So it can be either some more information, sorry, or you can also use that field to add some data that are useful for you when you do a search, because when you search, you can apply a regex on the key, but you can also apply a regex on the description. So typically, for example, if you want to use hashtags, maybe you can use that description field to ask hello, super, blah blah blah. That's kind of a handy way to do that. But here we don't have this. All right, so I got the key, I got the JSON, I need the headers, right? And for that, do I have like the shell somewhere here, or do I have to? I don't have that. Okay, so I'm lazy, so I just gonna have a look quickly where I've already done that. That way I don't have to reinvent the wheel. Okay, so here we gonna create some headers. Okay, and here there will be application.json, right? So there are two types of header on Juno. You can apply the header with your configuration, and then those headers are applied up to any assets. Well, depends on the regex you use, or you can define header each time you upload a file. And here, just for it's ND, because I don't have like the CLI and so on. I'm just gonna set it. All right. So finally, we need to pass the key, the content, and the headers, and everything forward. And here I just gonna bubble the errors, because I don't care that much about the user experience. And if the errors is bubbled, then just goes away, right? Okay, so I print we're gonna print here the name. Okay, and blah 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 blah. All right. Doesn't sound too bad, I think. Yeah, of course. That was too beautiful to be true. Okay. So clone here. I'm not sure it's there actually, but let name move occurs because name has type string, which is, does not apply the tray copy. Okay. Okay. So let's do that. That was not that. Not my day. Value borrowed. Yeah, it's always a bit stressful for me to do Rust in live coding because that's not my main skills. Nevertheless. So I know. Here. Still have one. Name. No. Borrow, move around. No. Move occurs because name has type 3 while does not return the copy tray. Okay. Here. Okay. And value moved here. Here, right? So I'm not gonna lose too much time here because I think we are good. So let me just I'm dumb. Name.clone here. I just had to read the error message, you know. Alright. Sorry for that. Okay, so bim bam boom. Yeah, so the issue is like you in Rust you cannot borrow multiple times the same resources. It checks that you have only one access to it. And yeah, I've badly put my code here, but here it's not a reference. It's really like I want a copy of the value, and that's why I clone it. And that way, this one is unique and this one is unique, and it's not like two times the same reference. All right. So what we gonna do? Test, super, test. Let's go. All right. So if it works well, here I should have let's go. Here, that's already done. And here you see I got the JSON. That's this output here with the name. That's the JSON file, right? And that's what I should get as JSON. So now we are uploading to nodes/name. So if I go to my browser, so look, I need the satellite ID, which is here. So satellite ID.localhost. Okay, that's the port of the local development. And here, technically, if I enter nodes and where is the key? Key here. I should get a JSON file. Yeah, like it's the small thing that makes me really happy. So here it's gonna be better formatted. So we see that worked out. So now every time we enter a new entry, it's the same thing that is done, blah, 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 and then we got a new entry. Etc., etc. Cool, no? Yeah, I mean, yeah, I don't know you, but I'm really happy with that already. So I'm gonna commit that. Just gonna format my code so that. So here we added our new collection nodes, and here we what we did. So let's say that we created a JSON, gave a name file, a collection, we created an asset key for this information, some headers, and then we put everything in the satellite. So here is like upload JSON file for each entry. Before we continue, I can maybe show you something. So exactly, that's the feeling. So yeah, I just thought maybe it's interesting to know under the hood how it works. So that function that we use, set asset handler, does the following. It gets the rules for the collection. So like here we have defined manage and manage, so it gets those rules. Then it checks if there is already an asset for that file, and if an asset was already uploaded, it's gonna check if, based on those rules, the caller has the rights to update those. And given that it's just a function for the serverless function, it basically uses the ID of the smart contract to perform that. And then, if everything is all right, it goes further. It creates a new empty asset. So an asset is the entity that is saved. And first, it uploads the chunks for the bytes, like for the content of the JSON. And when everything is persisted, it basically saves a reference to that, so that we can retrieve the file. And finally, it updates the certificate so that we are able to query that JSON file with the security without the need to use raw. So that means that we know that this is securely saved on the blockchain. And what's interesting here is that you see that I've used no compression, because right now it's maybe for the sake of simplicity. I just use the compression. For example, there is no gzip or other compression mechanism. So in the future, if anyone want to use that function, where was I? That function set handler, and here pass some compression, let's say gzip, that file is gzipped, just tell me, and then we extend it, because the satellite support identity, which is the term for no compression in web, and also gzip compress dflat and br. All right, so that stuff is cool, but I mean, now I have to go to my terminal to see what key was generated. So it would be nice also to retrieve the list of keys easily, right? So maybe we can publish another JSON file that contain the list of the other JSON file, if you know what I mean. So that would be that. Yeah, I really do like I just go for it, but otherwise I would create functions on. So what we can do is like list JSON assets, right? And to transform the list into a JSON string, and 3 do the same stuff here. That would be kind of cool. Actually, let's make a module, because I'm tense when there is so much files. So notes. Okay. So here I added a new module. Huh? So here we're gonna make a public function generate list of assets. Why not? Okay. And here we're gonna call that at the end. Okay. Right. So we need to get the list of files. So I think I also made that, added that to the patch this weekend. There should be a list asset store, you see. So let result. I have no idea what's in it. Okay, so what do we need to pass? We need to pass the color. So color is ourself, the smart contract, the collection. So okay, that's not really beautiful, but let's make a duplicate. What? Ooh, yes. And then we need to pass the list params. Okay. So, okay. Ah, that's dumb. It's not exposed. Okay, I gonna do if it was exposed, and we're gonna correct that afterwards. So we have a matcher, and we want to list everything. So we're just gonna go with the flow, and we're gonna go like give me everything. Okay, and that's a bit dumb. So here I gonna do params. That's not gonna compile, for sure. Okay, and you see this one gives also a potential error. So what we do here is we're gonna bubble the potential error. So here I bubble the errors and I return OK at the end, that everything works fine. And here I also bubble the error as previously. I don't care about the UX here, so if there is an error, there is an error. Okay, so we're gonna come back to that. So here we have the list now. Okay. If I check here, you know, it's the same as when you use the JavaScript library, and that's what interests us. It's the items. So what we're gonna do is, again, we're gonna encode the result items. Okay. Ah, interesting. Ah, you see, it's good. I'm really happy for that series, because that's two stuff that we need to add in Juno. So given that we still have a bit of time, I think that we go off road of of the grid, and we quickly do those things. So here I'm in Juno on main. So what do we need? We need to expose list param. So list params. Ah, that's from charret types. Actually, this says it's not too bad. So here, okay. So I've added that dependency, and now here, you see, I was able to fetch those, which is nice. Now the issue we have is that the assets. Yeah. No, but that's actually a good thing. We get asset no content, but here in those assets we have the key, the encodings, the which is like the content, or a reference to the content, when it was created, when it was updated, and a version. But what's interesting for us is just the key. And moreover, in the key, we are just interested in the full path. So, like, we want a JSON. So what we want the JSON we want to expose is basically, if I would do like a quick, what we probably want to expose is, let's say, that. For example, as a starter, we just want a JSON object that contains the list of things. So what we need to do is to map that to that JSON. So that's gonna be for just that JSON. Let list of keys, which is vector of string, right? And to do that, we're gonna do, I'm bad, I'm at Rust, so it's gonna be result.items.iter and map. And here we have the item, okay, which is a key and asset no content. So there is probably a better way to iterate to just have the keys, but I don't have right now that in mind. So here we can do, that's the asset, right? And here we can do asset dot key dot full path dot clone. Right, what's the error? Dot collect. And here now I can do that. So let me format and we show that. So what we did is I take the results. In the results, I took all the items and I say I want an iterator on those items. And then I do a map. And it's like doing object.entries in JavaScript. So you get the key and the value. So we are just interested in the value. And in the value, I know that I want key full path. And then I clone it and I collect it so that I transform it to a vector. And then here I do a JSON object, okay? And now to update the file, that's gonna be the same mumbo jumbo as before. So I just gonna, that's gonna be the exact same mumbo jumbo. So I'm not sure I want to we're gonna make a function because I don't want to repeat the code. So we need this. So here we're gonna make a function insert or upload. Let's make insert asset. Okay, maybe a function here. Okay, and what do we want? We want the name. Is that a string? I think so. And the JSON, which is this one. This one. So blah 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 print, blah blah collection, blah blah asset key, blah path. Okay. And here it just warns me because it's a duplicate. Because here you see I bubbled the error. Oh no. Without semicolon, it just means. So for those that are not familiar to Rust, like when you have the last colon, the last line in a function, so this is the same as that. Yeah, yeah, I say that, but yeah, really like Rust is not my main things. Anyway, so here we have an insert asset. So here I should be able to do name and what was the second param? The JSON object, huh? JSON object. No, that's a string. Okay, string. JSON. All right, and here we do that, and I can. Okay, and then here, if we go in our function, params, result, list, JSON. So here, technically, we gonna need a name. So let's call it notes.json, right? Don't know what I did. Okay. Oh, all right. Let's see. Incredible. Okay, so let's try, yeah? And let's see if it works. If not, we might have to debug. So now if super list, okay, sounds good. So we have generated a new entry, right? Super list checked. And because there were already two other entries, now we have generated an array with 3 entries. So if we take that one, here we should have notes.json. Ta-da! So cool. Yeah. That's cool, huh? All right. So I'm maybe gonna summarize and commit what we got. So because I think that's basically the solution. So let me here. So what we did first, or not first, but after I noticed that sometimes we're missing, we added that library here, Juno build shared, because sometimes we're missing. Juno build shared is a library used by all the smart contracts of Juno, where I basically put all the stuff that are used everywhere. Yeah, I don't have a better explanation. You know, like you're gonna find stuff like assertion, which maybe no one use, or all the, you know, like when you go in your in the console, and here, for example, you see the memory. So that comes from here because that memory here you have is on your satellites, but you also have it on your mission control and so on. Then you have some controller tools, some tools to convert dates and interact with the IC, blah, 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 blah. But you also have types, and that's the list where we find our list params, because that's types that are used everywhere. For example, that list params is used in the satellites, but I bet, yeah, it's also used in the storage crate, and so on. Then we created a new module, and we added a function generate list, because which we can basically, which we can, by the way, rename generate list of nodes, which does the following. One, search for all nodes in the collection, well, nodes. We don't pass any params because we want everything. Then we get the list, and here we map the list of items to their path, because we just want to have a list of this full path. And then we converted back the JSON to string. So, map results to the full path, which is the information we are interested in. Convert the list to a JSON string, and here and finally here we insert the JSON in the memory of the smart contract. Expose the content on the web. And what we did also is we took that function that was previously here coded within, and we extracted a function where we pass the name and just JSON, and here we generate the key, the headers, and we set the headers. And yeah, that's very good. So fit, what was that? That was fit generate nodes.json. So all right, and blah blah blah. Just gonna clean up things a bit. Okay. And I think that's good to be merged in the list of sample. So I'm just gonna see if in the other repository we had a readme. Yes. So do we have a readme here? Yes, but it's not what we need. So it's JSON, a sample, an example that showcases how to generate JSON file in serverless. Blockchain, this is cool. Function on Juno. So here, blah blah blah. First JSON, npICA, local development, npm run dev to develop the backend function Juno dev start. Yeah, it's really rough on the edges, but I will do, right? Okay, go. Simple description. And here, do we need something? No. Okay. Okay. Yeah, that's a wrap. So if you want to try it out, I've added it in the Juno build examples repo. If you come here, you have the Rust folder, and here we have JSON. So here we have developed an example of how to solve this with serverless function in Juno Live 1 and 2. The results are available in. Okay. One thing to note is that works fine, but there are some limitation in that things, because here we don't do much work. So if it's small data set, it works. But for example, here we are introducing we have introduced a list. So here I list everything in that collection, and then we do a collect. So that means that this counts like a search on everything, and then we filter again, and then we do the JSON. So if you would do that like in a productive application, you probably would need to do some metrics to see where are the limits, because I rather think it's like more for a small data set, that like a data set that gonna contains 1 million of entry. All right, yeah, basically it. So I don't know if anyone has question. If no, though, that was a wrap for the second June live. For the next edition, as always, feel free to ping me with your ideas. What I have in mind is actually would like to try to build a small app where we ultimately use serverless function to send notification. So the idea would like to have like a small app and then use serverless function, or yeah, not necessarily serverless function. Maybe have like some function somewhere that crawls also the backend, so that securely, and then transmit the information per email. Yeah, the idea would be that to have like one DApp where we had some kind of real-time notification. But again, if anyone have more question about the example we have built, I'm happy to dig deeper. Otherwise, yeah, thanks for joining. And scheduled function, is it feasible? So, is it technically possible? Is it supported right now? No. But yes, you can on the IC. So I can show you. Even the serverless function themselves are just a scheduled function with a 0 timer. So if where do I have that? Something hooks something. Yeah. No, not this one. You see here, should it work? No. Where do I have that? Here, you see, it's set timer. That's a function that comes from the IC CDK, set function. And I just pass 0, so they defer it, but you can pass a number of nanoseconds, and it's basically say in so much seconds start that command. And it's used in few PCs already in the code. You know, there is that canister that sends I don't know, like every hour a message if you have too little cycles left, and that's use a set timer too. So you see here, it's like so when I install that smart contract, it starts that job, and every hour it builds the crowns, it collects the data. So now maybe the send him. Yeah, so you cannot send the email on the IC itself. There is not an API to send email, but you can call a Web2 provider that send the email for you. So we can do that. So that would be an HTTP out calls. So either you have like a job that periodically checks if he should send email, or you do the other way around, like just like a push or pull, basically. Yeah. All right. So yeah, sounds cool. So yeah, maybe we can. I'm not sure we're gonna do the crown next week. Maybe we can first try to build like a small apps that does something, and then afterwards we build that email stuff. Yeah, I guess you can use HTTP out calls. The only thing is like HTTP out calls, you need basically when you do an. I gonna explain that in other. There are some limitations. It works well, but yeah, let's tackle that in another one. All right. Okay. So thanks everybody for attending. I hope you had. It was a nice session. I'm happy that it works smoothly, and enjoy your week, and see you next week. Bye bye.